All right, we are looking at lesson 4.8 today, which is going to talk about inverse trig functions. Okay, first thing I want to clarify with you, inverse is not the same as reciprocal, okay? I'll give you an example. If I said to take 3 times 5 and then perform the inverse operation, that would be like dividing by 5. Okay, so an inverse operation will undo what was just done. Okay, multiplication and division are inverses of each other. Reciprocals are just taking a value and flipping it. So a reciprocal is not really an operation like multiplication or division. A reciprocal is just flipping something upside down, okay? An inverse is actually a computation that will undo what was just done. So we've been studying reciprocal functions like secant, cosecant, cotangent. Those are all reciprocal functions. They are not inverse functions because they do not undo sine, cosine, and tangent. Okay, so what are the inverse functions, the things that will undo sine, cosine, and tangent? Well, we're going to look further at those today. Before we do that, we need to remember what an inverse function actually looks like. Okay, so your example here numerically is multiplication and division are inverses of each other. Let's look at something graphically. Okay, so we're going to look at x squared. So we need to first, I'm going to plot the graph of x squared, which that's just a parabola. Okay, and while I'm doing this, you can kind of be thinking in your head, you know, what would be the inverse of x squared? What will undo? What will undo x squared? So in your head, the inverse of x squared, the inverse of squaring a number, right? The inverse of squaring a number would be square rooting a number, right? It'll undo what you've done as far as squaring, and square rooting are the opposites of each other, so they are called inverses. Now, graphically, the way that we determine an inverse function requires a few steps, okay? Step 1, and I've got steps listed up here. Step 1 says the function has an inverse if and only if it is 1 to 1. So 1 to 1, that means it must pass something called the horizontal line test. So essentially, it's pretty simple. You just draw a horizontal line through your graph, and if it only crosses at one point, then you are 1 to 1. Now, a parabola is not 1 to 1 because if I draw a horizontal line right through here, it hits the graph twice. Okay? Step 2. If a function is not 1 to 1, which ours is not, you can restrict its domain and then find an inverse function. So restricting the domain, let's write this down. Restricting the domain is something that you will do just to basically make the graph 1 to 1. So essentially, the way that it looks, if this is symmetric, I want to take half of that symmetry piece off, leaving with only 1/2. Now, I usually leave the positive side, but we're restricting the domain down to 0 to infinity. So we're only looking at those x values of the graph, and we're going to make an inverse function from that. Okay, so that's restricting the domain. And then it says inverse functions have graphs that are reflected across the line y equals x. Okay, so if I drew a line that had a point at the origin and had a slope of 1, up 1 over 1, it would look kind of like this. I'm not going to draw a line, I'm just going to leave dots. But this would be the line y equals x. Okay? Inverse functions are symmetric about this line. So for me to draw the inverse of this x squared parabola, what I would want to do is I want to reflect it across this line, which can be a little tricky sometimes. So an easier way to do that reflection is to take the points that currently exist on your graph, 0, 0, 1, 1, and 2, 4, and you flip them. And when I say flip them, I mean flip the x's and the y's, okay? So the first 2 points are not going to move at all, but that third one would move to 4, 2. So let's graph those new points, and let's make a curve out of that, and then that ends up looking symmetric to the line y equals x, okay? So you have found your inverse function graphically, and number 4 was the strategy we used, switching the ordered pairs on the original function, okay? Algebraically, what is this inverse function? I can see it, but what is it as an equation? Well, it's the square root of x, okay? These are both parent functions. You should recognize them from previous things that we've learned. Okay, so that's your little preview refresher course on inverses. Now we're going to apply inverse functions to trigonometry, trig graphs. So I'm going to just point out right here, this is a slide with all the inverse properties. We've already discussed these at one point in time. But again, something on this slide that's super, super important for you to know is this, okay? Remember that when you are switching those ordered pairs to create an inverse function, you're also switching the domain and range. So what this means is the domain of a function is the same as the range of the inverse and vice versa. Okay, and that's an important feature to know because that's going to help us here in a moment. All right, inverse function number 1 is inverse sine. So I have over here this graph on the left. This graph says sine x, but you're probably looking at it going, no, that's not sine. Sine usually is like a wave and kind of goes down and keeps going over and over, right? Well, sine itself is not one-to-one. So you are seeing a restricted version of the sine wave, okay? So this is the sine wave. This is part of the sine wave. It's just been cut down so that we're looking at a piece that is one-to-one. Okay, remember that this step is required to create an inverse function. So this blue interval up here, that's the domain that currently exists after the restriction was done, okay? So there's my restricted sine wave, and it's cut from negative pi by 2 to pi by 2, again, to make it one-to-one. So we're going to pull the ordered pairs from that graph, and we're going to flip them, and that's going to give us the location of the points on sine's inverse function. Okay, so all these points here that were flipped get plotted onto a new graph, which we're going to call the graph of inverse sine. So this little -1 right there, that means inverse. It's not an exponent, even though it looks like one. It's an inverse notation. And you'll notice that the sine wave is also flipped like in concavity. See, this one kind of goes to the right and then up and then kind of to the left. So the way that it's bowed is even flipped because it's an inverse, okay? It should be a sort of a reflection, if you will. Okay, so the domain and range thing. What does this mean about the domain and the range of sine's inverse? Let me go down. When you look at this inverse function, actually, let's look at the original sine graph. Okay, so the original sine graph, we had to modify, right? We had to modify and make the domain smaller, and we cut it to negative pi by 2 to pi by 2. And then the range was the lowest and highest points. That's -1 to 1 on that first sine wave over there. The inverse function should have the same domain and range but flipped, okay? So for the inverse function, the domain is -1 to 1, and the range is negative pi by 2 to pi by 2. Okay, see how these two things flip? You could verify that by looking back at the graph again if you'd like. You need to make sure that you keep really good record of these inverse domain and range values as well as sines domain and range values, because that's going to be a necessary requirement for what we're about to do. All right. So here we go. So example 1, this is what your homework is going to look like, okay? Example 1, remember that the inverse sine graph has a domain of -1 to 1 and a range of negative pi by 2 to pi by 2. Use this information to find the exact values of the following problems. Okay, so step 1, you're going to check this value right here. And you're going to make sure that that is in the domain, meaning if it's in the domain, that means you're allowed to plug it in to get that function or to use that function. So is 1 in this domain interval? Yes. This bracket means 1's included, so that part is done. Step 2 is the thinking process, okay? So you have to think about how you're going to compute this inverse. So when you are doing mental math for these problems, you're going to ask yourself the question this way. This is an inverse, right? So what you're going to do is you're going to say something to the effect of, when is the sine curve or the sine wave equal to 1? When is the sine wave equal to 1? You're sort of thinking backwards since this is an inverse function. Now we do have a graph over here that we could just go to. Here's my inverse sine graph. I could look and say, when is the y value equal to 1? And I could maybe figure it out that way. But probably what we're going to want to do is we're going to want to think about the unit circle, okay? So let me pull up my unit circle here. And we're going to look at this unit circle to see if this gives us any more information. Now, obviously, you guys have already memorized these values, but we're going to take a second look. Maybe. There we go. Okay, so in my unit circle, what I'm looking for is when is the sine value, the y value, if you will, equal to 1? Right here, this y value, the sine function is equal to 1. That angle measurement is pi by 2 or 90 degrees. Okay, so that's what this inverse is actually asking you. So maybe you want to make a little note and you want to tell yourself how to read this in the future. When is sine equal to 1? Okay, and so the question we said would be pi by 2, and we think that would be the answer. Okay, but the last thing you're going to do to verify your work is you're going to go up here and say that my answer is representative of an output or a range value. Is it in the range interval? Yes, it is, because it's right here and there's a bracket beside it. All right, let's try again. So the second question is inverse sine of radical 2 over 2. So step 1 is you're going to check this value to make sure it is in the domain. And you may want to just type it into a calculator to see what it is as a decimal, because it's kind of hard to tell the way it's written. So radical 2 divided by 2 is actually 0.71. That is in the interval. So we are good to go. Step 2, we're going to ask ourselves this question. When is sine radical 2 over 2? Okay? When is sine radical 2 over 2? So you're going to pull up your unit circle again. Not that. You're going to pull up your unit circle. Come on, computer. There we go. When is sine radical 2 over 2? So radical 2 over 2, and that's the y value, right, for sine, looks like pi by 4, but I guess also 3 pi by 4, right? Because it's positive over here too. So this time we have two answers, okay? So it equals, let's write equals pi by 4 and 3 pi by 4. Okay, there were two places. However, The last thing you do, remember, is you're going to check your answer and you're going to make sure it's in the range values. Pi by 4 is in between these two values. 3 pi by 4 is bigger than pi by 2. Because remember, 3 pi by 4 is 135 degrees. Pi by 2 is 90 degrees. So this is much larger, meaning it is outside of the acceptable range values, so you will not include it in your answer. Okay, so this stuff can get a little bit tricky, so you really need to make sure you take your time and understand the whole process. Let's keep going. So the next one is inverse sine of negative 1/2. So the first thing I'm going to do is I'm going to check my x value to make sure it's in the domain. It is, so we're good to go. And then we're going to ask ourselves the question, when is sine negative 1/2? Okay, pull up your unit circle if you need to. Hopefully you could tell me that. Hopefully you could think about all the unit circle values you know and come up with an answer. So when is sine negative 1/2? I know this has to be in the third or fourth quadrants. And sine is 1/2, let's see, at pi by 6. So I would need 7 pi by 6 or 11 pi by 6. Let's verify. So negative 1/2 for sine, yeah, 7 pi by 6 or 11 pi by 6. Okay, so we have two answer choices. Let's write those down. 7 pi by 6, 11 pi by 6. And then don't forget, what's your last step? Your last step is to check and make sure those answers are in your range, acceptable range values. Okay? Curveball. Neither one of them are. 7 pi by 6 is way bigger than pi by 2. So is 11 pi by 6. So crap, does that mean that there's not an answer? Well, no. It's actually kind of a trick question, guys. Okay? Let me go back to the unit circle. Can you look at 11 pi by 6 one more time? 11 pi by 6 is right down here, right? Well, if we were to write this in a different way, we would be able to find an answer that does fit in the range values. We can use negative angle measurements to write different angles in a different manner. So for example, 11 pi by 6 is the same as negative pi by 6 because it's the same location, okay? So this is where it gets real tricky. You have to think about whether your answers fit in the interval, and if they do not, can you rewrite them in a way that it's still representative of the same location, right? But it fits in this interval, because negative pi by 6 does fit between these values. All right, last question on this slide. So inverse sine of 1/3. This one says estimate, and so what's happening here is you're still going to go through the process, but you're not going to be able to use the unit circle. So this is not on the unit circle. You're not going to be able to use the unit circle, so you're just going to use a calculator, okay? You're going to begin it the same way, though. You're going to see if 1/3 is in the domain. It is. So then you're going to grab a calculator, okay? So these little TI calculators work just fine. On your calculator, first thing, you're going to go to the very top row of buttons, and you're going to hit DRG. And you want to make sure your calculator is in radians. So you're going to have to go over to the middle option and make sure radians is underlined, okay? Once that is done, then you can go find your inverse sine button. So you're going to hit the second button and hit sine, and that should select inverse sine for you. And then just 1/3, close the parentheses, and enter. So for me, I am getting 0.3398. 0.3398. And then same as before, make sure that number is in your range of output values. 0.3398 would be in radians. If you wanted to maybe put it in degree mode and try it again, just to make some sense of it, you could do that. It is the same as 19.47 degrees. So I'll write both of those. 19.47 degrees. That might be easier to kind of think through because I know this is 90 and this is negative 90 degrees. And so now I know, yeah, it's in the interval.